online class, we got you. Wherever you want it from, we got what you need. Toilet online class, we got you.
Good day, everyone. Once again, you are welcome to Toilet online class. Just as I've introduced the set of numbers, so the first set of numbers, the first set of numbers are called the natural numbers. The natural numbers. So denoted, this one is denoted as n, as we have it on the board. Good morning. Good day, lovers all over the world. You are welcome to Toilet online class. Today we want to look at the derivative of a trigonometric function. Of course, trigonometric functions, there are so many functions, but today we want to concentrate on trig function. So, and if you want to know more about trig functions, you can just check my videos on trigonometric functions. So we want to look at derivative of trigonometric function. That is, we want to see how we can differentiate trig function. So if y is sine s, that is, in this case now, this function is trig because we have sine, cosine, tangent, cotangent, cosec, sec, and what have you. So if y is sine function of x, then the derivative dy dx is given as cos x. So we should note that. So if y is equal to cos x, then the derivative dy dx is equal to minus sine x. That's what you get. Then if y is equal to tan x, then dy dx will be equal to sec square x. Okay. So if y is equal to, we have so many functions, sec x, then dy dx will be equal to sec x tan x. Okay. If y is equal to cosec x, then dy dx will be equal to minus cosec x cot x. That's what you get. Then finally, if y is equal to cot x, then dy dx will be equal to minus cosec squared x. So that is what we are going to have. And of course, we can prove all this. Using differentiation from the first principle. We can actually prove everything that we have on the board using differentiation from the first principle. So we can prove this. We can actually show this. So if y is equal to sine x, dy dx is given as cos x. But if y is equal to cos x, dy dx is negative sine x. Then if y is equal to tan x, dy dx is equal to sec square x. So if y is sec x, dy dx is equal to sec x tan x. Then if y is cosec x, dy dx is minus cosec x cot x. Then if y is cot x, dy dx is minus cosec square x. So we can actually prove this. We can actually show everything using differentiation from the first principle. So we should know that. Then if you come across any standard textbooks, all this, we can actually get all this there. So, but our purpose in this teaching is not to prove, but to just teach us on how we can actually find the derivative of trigonometric function. So I'm going to introduce that by giving example. Find the derivative of each of the following. The first one is where you have sine 6x. Then we have tan 4x. Then C See, maybe let's say we have cos 3x. So how do we solve this? The first one we say y is equal to sine 6x. You know, when you check the formula what I gave us the other time, all the coefficient of x there is just one. We talk about sine x, cos x, tan s, sec s, cot s, cosec x. But in this case now, x has a variable that is more than one. So how do we solve this? Then this is what we do. We can just represent. You can say let's just put u to be equal to 6x. Okay, so that y will not be equal to sine u. Then dy du will be equal to, when you differentiate sign, get cos u. But in this case now, we decide to represent u as sine 6x. Then we also find du dx. That will be equal to 6. So that dy dx at the end of the day will now be dy, that will be du dx multiplied by dy du. Of course, du can take care of du. That's what we get. What is du dx? That is 6. Then dy du is cos u. But we are given the question in the form of x, so we substitute back. We now have 6 cos 6x. So if y is equal to sine x, then the derivative will be 6 cos x. So instead of going through all this process, what you do is that if you have to find the derivative of trigonometric function, check the variable, check what you are given, what you have, the angle in front of that trig, differentiate this before you now find the derivative of the sine of the trigonometric function. Just use it to multiply. For instance, here we have sine 6x. Just differentiate 6x. 6x is going to give us 6. At the end of the day, we are going to have the derivative of sine is cos. That we now have 6 cos 6x. So that is how to find the derivative of a trigonometric function. The second one now, where we have y is equal to tan 4x. Without going through any stress here, of course, we can just know the answer. If I differentiate this for 4x, I'm going to get 4. Then what is the derivative of tan? Tan is sec square. So dy dx in this case will now be 4 sec square 4x. That is what I'm going to get. That will be the answer. Of course, we can show it. Let me just show it. But once I get to this third example, I won't show anything. I will say let u put u to be equal to 4x, so that du dx will be equal to 4. Then what we have left, our y will now be equal to tan u. What is the derivative of tan? Dy du will now be sec square u. Then finally, dy dx will now be equal to du dx multiplied by dy du. Of course, if you multiply this, you are going to get dy dx. Since we can't get it directly, this will now be 4 sec square u. Then at the end of the day, we are going to have 4 sec square 4x, and that is what we are expected to get. So without going through this process now, for instance, if you have a multiple choice question, objective questions, multiple choice, maybe you find the derivative of this, a sec x, b tan x. So how do you get your answer quickly without going through any stress? That's what we are trying to do here. So what is expected is that differentiate what you have here. Then what is the derivative of tan? That's x squared. Just use what the result you got here. Use it to multiply the derivative of this, and that will be the final answer. Then the third one, the third question under example 1, C, is where you have y to be equal to cos 3x. Then without going through any process here, the y dx will be derivative of this is 3. What is derivative of cos? If we differentiate cos, it's minus sign. So I will have minus sine 3x, and that's the answer. How do I get this? Just follow this process. You are going to get what I have here. So that will be the answer without going through any stress. You just get the answer straight away. So that will be the answer. That is what we are going to get. So let's take another example. Example 2. Let's take another example. Let's take another example. So example 2. Here we have to find the derivative of a sec 8x, then b cot 1 plus x. Then let's say e or c. We have cosec x squared. So we follow the same process. If y is equal to sec 8x, what we are expected to do here is that we put u to be equal to 8x, so that du dx will be equal to 8. Then therefore y will now be equal to sec u. What is dy du? If you check what we are given, when we differentiate sec, we are going to have, this is going to give us sec u tan u. As I've said earlier on, we can actually prove this. Sec is 1 over cosine. If I use differentiation from the first principle, check my video on differentiation from the first principle. When you follow the step, you're going to get this. Okay, so that finally dy dx will now be du dx multiplied by dy du, and that will give us du dx is 8. That will be 8 sec u tan u, and that's going to be 8 sec u is 8x sec 8x tan 8x, and that's what we are going to get. So you can actually get this straight away without going through this process. Once you know that if y is sec x or sec whatever, dy du or dy dx, depending on the function that you are given, will be sec u tan u. So once you know that, then you won't have any problem. So we go to the second question, where we have y to be equal to cot 1 plus x. So we say let u to be equal to 1 plus x. So what is du dx will be equal to what? 1. Du dx in this case will be 1. So that y will now be equal to cot u. Then if y is equal to cot u, dy du, when we have cot, dy du will be minus cosec square u. That is what we have there. That's what we are going to get when you check when I started the formula that I gave. If y is equal to cot x, dy dx will be minus cosec square x. So in this case now, dy dx will now be equal to du dx multiplied by dy du, and in this case du dx is 1 multiplied by minus cosec square u. That's what we are going to get. At the end of the day, we are going to have minus cosec square u. And what is u? That will be minus cosec square u is 1 plus x, and that will be the final answer. So I want us to check this very well. Let's take our time to check this example. So instead of going through all this process, if you know what to do, just go ahead and differentiate the angle that you have there, 1 plus x. Use it to multiply the derivative of cot c. So that is what is expected. Once you do that, then straight away you're going to get your answer without going through any stress. So we go to the last question under example 2. We go to the last question under example 2, where we have y to be equal to cosec s squared. If y is equal to cosec s squared, then what are we going to do? So we can say let u equal to s squared, so that we know du dx. Du dx will be 2x. Then we come back here and say y is equal to cosec u. Then what is dy du? Dy du, in this case, when we have y to be cosec u, dy du will be minus cosec u cot u. That is what we are going to get. So that finally dy dx will not be equal to du dx multiplied by dy du. So du dx is 2x. Then multiplying minus cosec u cot u. If you do that, we are going to have minus 2 cosec u cot u. Then what is u? U is s squared. So we are going to get minus 2 cosec s squared cot s squared. And that is what we are going to get as the final answer. So under trigonometric functions, it is expected that we should know trigonometric ratio. We should have the knowledge of trig before we be able to express all this. Let's know the meaning of sec, know the meaning of cot, know the meaning of cosec. These are reciprocal. Sec is reciprocal of cos. Cot is reciprocal of tangent, tan. Then cosec is reciprocal of sine. So please, for you to have proper understanding on this concept, you check my video on trig. I have about 4 or 5 videos on trigonometry. So please go through my videos on trig so that you can have proper understanding about this concept. So let's take the final example. Then in this case now, we have to find 1 plus tan u, no, tan x all over sine x. So in this case now, we have it in form of quotient. If you have problem in form of quotient, what do we do? 1 plus cos 2x all over sine 2x. So what do we do here? The first one, when y is equal to 1 plus tan x all over sine x. So I want to say that for you to have proper understanding about this concept, I think I have about 6 or 7 videos on differentiation. We've talked about differentiation from the first principle, function of a function, differentiation of polynomials. We've talked about derivative of a product, that's product rule. We have talked about derivative of quotient, that's quotient rule. So please go through everything so that we'll be able to understand what I'm about to do now. In this case now, this is in form of fraction, it's quotient. So how do I differentiate this? Of course, under quotient rule, we know quotient rule will actually guide us on what to do. Under quotient rule, I know that I'm going to denote the numerator as u, and the denominator, I will denote the numerator as u and the denominator as v. That is what is expected here. So I will say I will let u to represent the numerator 1 plus tan x. Then what is du dx? Du dx will now be equal to differentiation of a constant is 0. But differentiation of tan is sec square x. Then also v, the denominator, is equal to sine x. That is sine x. Then the v dx, in this case, the v dx will be, when I have sine, it is cos x. Then how do I get the derivative here? Dy dx here is going to give me v du dx minus u dv dx all over v squared. Please, let's take note of this. When you have a function that is fractional, a quotient, in form of a quotient, this is how to find it. So please check my video on quotient rule, derivative of a quotient. So that will actually guide us. We have done a lot of example on polynomial functions. So in this case now, dy dx will just be, we substitute for v. We are going to substitute for v. In this case now, v is what? Sine x. Yeah, v is equal to sine x. I have sine x multiplied by du dx. Du dx in this case is sec square x. Then minus u. U is equal to 1 plus tan x multiplied by dv dx. dv dx is cos x all over sine x all squared. That's what we are going to get. So that's what we are going to get. So we now simplify further. And if you do that, I'm going to have sine x, yes, sine x sec square x minus, if I open up here, cos can multiply this minus cos x, then minus cos x tan x, everything all over sine x all square, same thing as sine square x, and that's what we are going to get. So that's where we stop. So if you want to simplify further, you can use the fundamental identity. You only apply it here. I can check this sec to be 1 minus this sec. It has its value. Sec is 1 over cos. So if you want to simplify further from what we have here, we make use of a fundamental identity, which is sine square x plus cos square x is equal to 1. But we can just stop. You can stop the answer at this point. So we go to the second example. Let's go to the second example where we have y. The second example where we have y to be equal to 1 plus cos 2x all over 1 minus all over sine 2x. So in this case now, we represent the numerator as u, that's 1 plus cos 2x, then the denominator v sine 2x. Of course, the u dx in this case now, when we differentiate constant is 0. The derivative of a constant is 0. So when we have cos 2x, we are going to differentiate this 2x. 2x will give us 2. Then what is the derivative of course? Minus sine. So I'm going to get minus 2 sine 2x straight away. Then the v dx will be, when I differentiate this, I'm going to get 2. Derivative of sine is cos. That will be cos 2x. So when you check first example, you will understand this. I just try to do this straight away so that I won't waste time. Then dy dx will now be equal to v du dx minus u dv dx. Please, you check my video on all over v square on derivative of a quotient. So once you check my video on derivative of a quotient, you won't have any problem. So what is v here? Sine 2x multiplied by du dx. Du dx is minus 2 sine 2x. Then minus u. U is 1 plus 2, 1 plus cos 2x into bracket dv dx is 2 cos 2x. Everything all over sine 2x all squared. That's what we are going to get. So we simplify further. From there, we are going to have, if I should open up, I'm going to get minus 2 sine 2x multiplied by sine 2x. That minus 2 sine square 2x. That's what I'm going to get there. I'll get minus 2 sine square 2x minus, this will be minus 2 cos 2x, then minus cos 2x. This will be 2 cos square 2x. Everything all over sine square 2x. That's what I'm going to get at the denominator. Then if that is taken, I can try to bring out 2. I can bring out 2 or minus 2. Minus 2 is common to everything. So if I bring out minus 2, I'm going to have, once I bring out minus 2, I'm going to have sine square 2x plus 2. No, I brought out 2 already. Plus cos 2x plus cos square 2x. Everything all over sine 2x, sine square 2x. We now recall. We recall that we recall that sine square 2x plus cos square 2x is equal to 1. That is from fundamental identity. So under fundamental, from the fundamental identity, that's what we are going to have. So from there now, I'm going to have minus 2 into brackets. I will combine these two together. Sine square 2x plus cos square 2x plus cos 2x. Everything all over sine square 2x. So sine square 2x plus cos square 2x is going to give me 1. So dy dx will now be equal to minus 2 into bracket 1 plus cos 2x all over sine square 2x. And that's what you are going to get. You can try to stop your answer at that point, or you might decide to simplify further. So without the knowledge of trig, I will not know that I can change sine square 2x plus cos square 2x to 1. So please, to have proper understanding about the derivative of trigonometric function, please check my videos on trig. I have about 4 or 5 videos on trig. So study trig very well. Once you have proper understanding about trig, then it's going to help. It will be of assistance whenever you want to find the derivative of a trigonometric functions. So I would love to stop here because of our time. Thank you for listening, and God bless you all.